Okay, Magdalena Nowak is going to tell us how to make the PySparks fly. So yeah, please welcome Magdalena and let's start the presentation.
Hello everyone and welcome to my talk, Make the PySparks Fly. I assume you're here to make your PySparks fly, whatever that means. I just thought it's a cool name. So a few words about me. Currently, I'm a senior staff engineer at Stellantis, and I have 10 years of experience in what was first called data analytics, and then turned into machine learning. And actually, I have also 5 years of experience. This is my 5th year talking at Data Science Summit, so an anniversary for me. I'm quite glad to be here. And while I'm a mathematician, this time there will be absolutely no formulas. There will be only code. So I hope you like Python as much as I do. Okay, so we don't have much time. Yeah, we have around 30 minutes. And normally a presentation like this should start with some sort of introduction to Spark. But I thought this is a data science conference, so I will give you the sort of introduction to Spark that the data scientists get, which is about zero introduction. It's just like Pandas, right? How many of you actually use Spark in your everyday job? Okay, quite a few. Many of you had formal training in Spark? Yeah, like 10 people maybe? Okay, so that's probably, I was probably right saying that. And yeah, so let's get started. I think like most of data science projects I ever seen converge to either of these two solutions. First, it's like you just copy your SQL queries, and yeah, that's the lazy way, obviously. But now you are using big data from a huge table, so you execute your query with Spark. Well, some of you might want, you got this formal training, yeah, all 10 of you, so you might want to do this the right way. You first create your data frame, and then you select columns, then you use a filter. But then, in 99% of projects, what happens is I see this line. So, I mean, why wouldn't you do that? And here's why. Wait, let's check if the video works. Yeah, when you Google PySpark to Pandas, you have a curious set of results. Most frequent questions: out of memory error, limit, very slow, not working. Yeah, and that's probably what I saw the first time I Googled my problems. And why is that? So, despite this lack of formal training, you probably read the PySpark docs, yeah, like everybody did. But I'm quite sure most of you have missed this small note. This method should only be used if the resulting Pandas data frame is expected to be small and all the data is loaded into the driver's memory. And all of you who had this formal training in PySpark, what exactly is a driver? And how do you control its memory? Obviously, you know that, right? As you were given this amazing data scientist introduction to PySpark. Well, but since you're probably, it would be nice to actually learn PySpark, right? Instead of resorting to Pandas, especially since you see it's not the best solution for you. So why would you still want to use Pandas? Well, because a lot of things are impossible to do in PySpark, or you might just think it's impossible. Yes, maybe nobody actually wanted to do that on Stack Overflow, so you cannot find your solution. But also, rewriting all your Pandas code base to PySpark code is both difficult and time-consuming. I remember a time when I just asked a colleague, you know, this Pandas this UDF, I'm a bit spoilering the rest of my presentation, could be actually PySpark code. And he said, okay. And then it took him like 8 hours to actually do it, but he managed to do it in pure PySpark in the end. So that was a learning experience for us both. But most importantly, import Pandas as PD. So who wrote this line in their life? What? Like, no. Okay, you are scaring me there. That's your comfort zone as a data scientist, right? You know Pandas, you've learned Pandas. So this is like the beginning of all that all there is. You probably work best with what you know best. So what can you do instead? Again, time constraints, so we are limited to a subset of solutions that PySpark offers. We'll be skipping the new PySpark Pandas API, which is, I guess, a topic for another talk. We'll be missing everything to do with RDDs. And when it comes to training models, we'll also skip the existence of Spark ML for a moment. Okay, so who has heard about UDFs, user-defined functions? I hope some of you, yeah, all those people who had formal training obviously raised their hands. For the rest of you, they basically allow you to extend PySpark functionalities by writing Python native code. And then you can just execute this code without collecting the data, right? So that's an amazing thing, probably. But they also operate one row at a time and require data movement between JVM and Python. Those of you who with the formal training and so on, you obviously know how Spark works internally, but basically it's Java underneath. And the movement of data from Java to Python doesn't come at zero cost, or it used to come at non-zero cost. But also Spark praises itself as being something that is very well optimized. And when you are running Python code, there's zero way to actually use these optimizations. All of this leads to significant bottlenecks that you might experience in your code. Well, you can probably see that this all shapes into pros and cons. So why would we still do that? Because it's very easy. How to create a UDF? As you can see here, it's just a decorator that you use over your function that accepts a single value, returns a single value. You need to specify the return type. You can also wrap it with the UDF function itself. And then you just use it as any other function. Yeah, quite easy. So let's look at this performance I told you already. So we'll be using this fake example of add one function throughout all the examples. Don't pay attention to the exact numbers. It's just I ran the code on a huge table on the cheapest Databricks cluster, and it was 30 times slower than the Spark native code, which isn't very good. Well, can we do better? And the subtitle, Run Python Code with PySpark Fast, comes from a Databricks blog post that came with introduction of Pandas UDFs. They were introduced in Spark 2.3, so like 5 years ago, but they actually experienced a major overhaul with Spark 3.0. So how many of you learned Spark before the pandemic started and haven't updated your knowledge much? So Spark 3.0 is June 2020. So if you didn't learn much after that date, you're missing a lot of cool stuff that we'll talk about today. So Pandas UDFs significantly improve the performance of the UDFs. Underneath, it's Apache Arrow that you might have heard about. This is basically, you can think of it as a way to send this data from Java to Python at almost zero cost. Yes, it's a standardization format that allows you to move the data super fast with absolutely zero costs. And most importantly, to us using the two pandas method a lot, inside those functions, you can use Pandas API. Okay, so let's have a look at how do we actually create those Pandas UDFs. So again, we can see here, now we are getting a Pandas series and outputting a Pandas series. So you can think of this improvement as a sort of vectorization of those operations. Well, you again set return type and a function type. Obviously, easy to remember, Pandas UDF type scalar. This is one of 6 UDF types. We are talking about Spark 2.3 again. Usage, the same. Very easy, especially if you remember all those 6 types, especially as the type controls your input and output. And this is a cool story about how Spark community actually works, because when people were working, adding all those new UDF types, people stopped using them because they were not easy to use, they were not intuitive to use. Basically, imagine you have 6 types of UDFs and you need to always make a decision which one to use. Well, people had already problems with regular UDFs, okay? So before June 2020, in version 3.0, all of this was changed, yes? So now if you are using those old types, you are going to get this user warning about a new specification. This new specification makes use of typing. We had a session on typing before, so I guess you guys are probably familiar. And here, instead of specifying some sort of type, you can see that the function type, you can see that we instead show the typing for our input and output. And here it's a Pandas series, and we output a Pandas series. That's one of the 3 major types of Pandas UDFs, series to series. That's the one originally introduced. It was called scalar. Well, it comes with one, basically it maps one series to another. The length of this input must be the same as the length of your output. You can add more series, yes, you have an example here with adding 2 columns. Well, but imagine you're a data scientist, so you don't have to use your imagination here. If you want to score your data with a model, it does, like, you load a model and it takes time. And you don't want to reload your model every time you want to score some series, right? So instead, there comes this new type, again, June 2020. We are given the new type iterator of series to iterator of series. And it can be used when you have a costly initialization. So you just, for example, put your model loading here, and then you reuse this initialized object again and again. So it's used the same way, but it's very convenient if you have some sort of heavy object, not just models, some sort of classes that are costly, whatever. Okay, so here we mostly handled like series to series. Those series had to be equal in length. But let's now look at another thing you can do, aggregation. So you also have the series to scalar type. And this one used to be already included in Spark 2.4. And again, you can have 1 or more series and then output just one number for this series. And this number needs to be like a primitive data type. So you can see here, for example, we summarize a series to a float. Well, it looks good, right? But these are things that are easy to do. Let's have a look at the performance. So now we have 3 functions, the original Python one, the original Spark one, our UDF, and our Pandas UDF. As you can see, switching for a UDF to Pandas UDF didn't require much work, just typing. So let's have a look. The performance is 3 times better, but still 10 times worse than Spark Native. But let's be real. If you want to use UDFs, you don't do this to add 1, right, to your row, because this is like the simplest thing you can do in Spark. So the main example used in this paper I told you about, the Databricks ones, was a cumulative probability function from SciPy package. And they got even better results that I did, but I wanted to keep it consistent for you. So that was 200 times faster for me, as soon as there was, some more complexity in handling the data. And for them, I think it was 300, so it was even better. Imagine sitting for 400 seconds to wait for your results. Yes, like you can make coffee in this time, I guess. And instead, you don't get to drink your coffee if you use the Pandas UDF, because it's just 2 seconds, yeah, maybe a sip. Okay, so as you can see, the main thing here is now you cannot compare it with Spark because Spark doesn't offer this option, right? Okay, so we've wrapped up the part about series, and every time I hear that something can be done on series, I think, can it be done on the entire data frame, right? So what else is there? Another thing that was introduced this time, pandemic, June 2020, and there are Pandas function APIs, yes? The internal workings are basically the same as with Pandas UDFs, but they, you no longer need a wrapper, you don't need to specify a report type. No, now it's worse. You need to specify a whole schema for your output data frame, because those new function APIs allow you to output an entire data frame. And this data frame doesn't have to have the same schema that your initial data frame has, and it doesn't have to have the same length. You can transform it however you want, yes? And internally, again, you use Pandas. This time, a Pandas data frame. So there are two of those. First, they are conveniently named. One, the map one is called map in Pandas, and this one again accepts an iterator of Pandas data frames. This time there's no like a raw way of just transforming data frame to data frame. You always need this iterator, so there's always a bit more to write. And as you can see, no wrappers. The type hints are actually not obligatory, but I use type hints anyway. And then you just call it with map in Pandas, you use your function, and then you need your schema. This time we got off cheap because I just used the same schema as our input table had. But as I said, you can transform your data whichever way you like. And this sort of function, just how does it work? It maps your data, it grabs batches of it on each partition, and you can control this batch size with some parameter. So basically, it speeds up things significantly again. Another type is grouped map, which this time not so conveniently named, we use with apply in Pandas. So let's have a look. This time it's like the familiar split, apply, and combine way of working with your code. So you use this on grouped data, and then each group has to fit into memory, which is something, again, that people who use Spark and are data scientists and not data engineers don't usually need to worry about and don't know how to control. So we will see a quick example on how to have a look at this later. But again, your input is a data frame, and you, this time, grouped data, yeah? And on this grouped data, you can perform any sort of operation you want, as long as it's data, it's in Pandas, right? Okay, but probably you are thinking, okay, all those function types, all those UDFs, what am I going to do with them? So let's have a look at some practical examples. What do you do as a data scientist? Use train models and you score data with models. That's probably the extent of it. And that's going to be a lot of code, but what we are doing here? First, we have a completely normal Pandas code, right? So let's grab some, well, what else to use at a conference but the iris data sets? Obviously, this reflects the sort of job you do daily very well. So let's create a iris data set with nicely named columns. And then let's write a function that you probably written in some way in all your life. So what do we have here? We have a prediction from some sort of model. Then we have a prediction of the probabilities as a list. And then we also, just because I wanted some string columns, we will add the names. So we load our model, and then we use the predict function on our data frame. We get the results here, so familiar probably columns, and then prediction, pred proba, and pred name. This is all Pandas code, right? So now let's see how can we easily transform it into PySpark code. So first we create a data frame from the iris data set. And we need to declare this schema. Yeah, there's no going to go around that. So what do we have here? We have all the schema fields from the original data frame. And then we add prediction, which is integer type, pred name, string type, and pred proba, which is an array of floats. As you can see, easy. It didn't take us much work to do this, to set up this schema. And then we write a wrapper for our predict function. As you probably remember, we need this iterator of data frames here. Yeah, so we iterate the data, we load the model. As you remember, that's the avoiding the repeating the costly initialization here. And then we just yield the predict function of Pandas df that it gets, yes, our argument. And then the model we've just loaded. Remember, like this predict function, that's the function that used to be set on Pandas data frame. You just can grab it from your any Pandas related flow, yes? And then you can use just on your data, on your iris df. This time, this is a Spark data frame. You use the map in Pandas method. You use the predict underscore wrapper. You declare the schema we've just created. And let's have a look at the result. Well, they are the same results. I guess you are surprised it worked this easily. But I don't know if somebody noticed the only difference between those two results. Yeah, probably nobody read it that carefully. But I actually switched the order in the schema, yeah? So before pred proba came before pred name. And that's the cool thing, that when you specify this schema, even if the underlying data frame you're returning has a different order of columns, it will still adhere to this schema and will return the data frame in a nice form. As a data scientist who had to struggle with matplotlib and its crazy way of handling order of variables and so on, even named, yeah, that was a huge gain. So we have scored our data with a model we had, but now let's move to another thing. So using Spark to distribute model training, and that's actually, I think, the way cooler application. And first, let's create some data this time. Probably reading this, it's not very user-friendly, but what happens here? I create 80 million rows, and each there will be 8 groups. Yes, each will have 10 million rows, and those groups will have some random data in it. That's the column X. And then I will want to add Y as this formula. Yeah, Y will be 40 times X plus the group ID as the intercept, right? I'm adding some noise so that the results aren't too perfect. But let's see if we can train models for all those 8 groups, yes, simultaneously making use of parallelization. Who remembers what I said about groupBys and some caveats with its use? So we need to control the memory size. How many of you know how to actually tell how much data, how much memory does this data take? Maybe there are some people who want to do this with me. If not, let's just add. We have an integer. That's the ID column. That's 4 bytes. We have 2 double columns, X and Y. That's 8 bytes each. Yeah, so together that's 20 bytes per rows. And each of our groups are going to have 10 millions of rows, right? 20 megabytes, right? I'm not good. I'm a mathematician and I'm not good at calculating fast, but I think it's 20 megabytes. So that's obviously probably going to be enough data for us. Sorry, not too much data for us to fit into our executor. So let's now train the models. Okay, so let's not be too ambitious here. Linear regression should work well for our case. So here's another cool trick. our train model will get another input, not just the data frame. It will get what I'm calling here group keys. And what is this group keys going to be? When we do the data frame group by ID and apply in Pandas, it allows you to both send the data frame and what's actually in the group, yeah? So for each group, under these group keys, we will get the ID of the group as a tuple, yeah? A tuple with one element. So it will be 1, 2, up to 8. And we will make just setting up our models, fitting it obviously to the data. We can also calculate some sort of score for it, or let's do R squared. And here's another surprise. You don't just need to do like Pandas transformations, right? You can also add some extra stuff here. For example, here I'm adding a function, some sort of function to store the model somewhere. So we've just stored the model we've trained, and it's all parallelized. So let's output something. We will output the group keys, which is just the model ID, the coefficients of the model, and R squared, yes. Our columns will be model ID, coefficient, intercept, and R squared. And as you can see, I defined the same schema here, okay? So model ID is an integer, coefficient and intercept are float, R squared is also a float. And let's have a look at the models we trained, not the data and models we stored. It's a bit far from me, but as you can see, our models are great. They are like, I'm quite impressed with them. So for each group, the coefficient is around 42, and the intercept goes 1, 2, 3, 4, and so on, corresponding to the model ID, just as our formula gave us. And the R squared are, yeah, I hope you are seeing those numbers in your everyday work without data leakage and without overtraining. And actually, that might be a good way to wrap up now, so that I wish you would get those numbers as often as possible. Okay, so let's conclude here. Thank you. And you can rate my presentation using this QR code. You can also add questions there, right? And if you have any questions here, I think we still have some time.
Yeah, we have 10 minutes. Yeah, but please give a round of applause for Magdalena. So raise your hands if you have questions.
What do you think about koalas?
I haven't used it really, koalas, polars, yeah. I'm sticking with PySpark, to be honest, because it's my favorite.
Any more questions?
Well, nothing lost. You can still ask those on under the QR code. Thank you.